This unit is a review of the work you completed in lab where you had to transform a distance measurement into a frequency value in the pitch control part of your theorem. All sensors have limitations in terms of their operation. At a minimum, you need to understand what the minimum value is that they can measure, the maximum value they can measure, and what their sensitivity is. You would need to read these values off of the spec sheet that accompanies the device. In the case of the distance sensor, the values we will be working with are Lmin, which is the lower limit, the lower distance limit that it can measure. So your sensor will not read anything below Lmin. It cannot differentiate or read anything above Lmax. It'll max out at that value. And the sensor can't tell the difference between a distance that is between distances that are between 0.3 centimeters of one another. So, for example, in our case, the sensitivity was 0.3 centimeters, so your sensor would not be able to tell the difference between, say, 1.5 centimeters and 1.7 centimeters. The added wrinkle, of course, is that you're trying to program a device, and no programs at this point can work with fully analog numbers. Everything has to be discretized, so even if your sensor is completely analog, once you start programming and controlling it through software, you have to discretize it. So here again are your important known parameters: your maximum detectable distance, your minimum detectable distance, your precision, delta L, and now you need to figure out how to use these parameters in order to discretize your device for optimal operation. So what do you calculate? You need to calculate the distance between Lmin and Lmax, and that's capital delta L. And then you need to calculate how many little delta L's fit into one large delta L. So if Lmin is 1 centimeter, Lmax is 11 centimeters, and little delta L is 1 centimeter, then your overall distance, measurable distance, is 10 centimeters. And so you can fit capital delta L over a little delta L, which is 10 over 1, so you can fit 10 units in your between your minimum and maximum distance. So really what you're doing is you're redefining your unit to correspond to a step size that evenly fits within your full allowable range of motion, and ideally, in order to completely optimally use your device, that step size is going to be equal to its sensitivity. So in this case, which is a simplification of your problem, your step size was 1 centimeter, and you can fit 10 of those step sizes within the maximum distance delta L. So to continue the example, your total number of units that fit within this large delta L is 10. And if your hand moves now from Lmax down to some distance d, you need now to express the actual distance reading in terms of your new unit delta L. So you need to figure out how many delta L's fit into it. If you divide d minus Lmin, remember your delta L doesn't start until after Lmin, and take the integer value of the result, you will get the number of delta L's for that particular length, that fit into that particular length. In your situation, you can see that your hand is at about 7 centimeters, minus 1 centimeter over 1 centimeter is 6. So taking that same delta L and checking your work, you'll see that in fact you can fit about 6 delta L's between Lmin and your hand. So now you need to figure out what frequency this integer value should correspond to. So you're taking your distance measurement, you're sending it to the Arduino, pins 22 and 23 in this case, and you've calculated within your Arduino that corresponds to 6 steps up from your minimum distance, and somehow you need to transform that into a frequency value, which you will then use to generate a sound of a specific pitch. So what's sound? Sound is frequency. So let's take Lmin and relate it to Fmin, and Lmax and relate it to Fmax. And what you're doing is you're discretizing your frequency scale in the same way that you discretized your distance scale. So you started out with 10 discretized values in your distance, so you need 10 discretized values in your frequency scale. That gives you a delta F of F max minus F min over N total. And then your F is going to be 6 up from F min. So it's going to be F min plus N times delta F. And those are the calculations that you performed in your Arduino program to calculate your F pitch. You would use the similar philosophy to translate a distance measurement into a potentiometer value. Now you have to be careful for your potentiometer that it just needs the integer value 6, and the potentiometer works a little bit differently than the frequency scale, because your potentiometer scale only has 256 values. So in fact, it is a potentiometer scale that is limiting your between L max and L min what your minimum distance unit is going to be.